All right, 4.6 part 3. We did example 2 yesterday, so we have 1 and 3 to do today. So example 1 says water leaking into a floor forms a circular pool. The radius of the pool increases at a rate of 4 centimeters per minute. How fast is the area of the pool increasing when the radius is 5 centimeters? So what's the shape that we have here? A circle, thank you. And what is it asking about that circle? What's changing here? The radius is changing, but what's the question asking? How fast is the area of the pool changing? So what's the area of a circle formula? Pi r squared, perfect. So we could label everything first, or if you want to take the derivative first and then label everything, that's fine. Let's go through our question and we'll label things. It says the radius of the pool increases at a rate of 4 centimeters per minute. So what would 4 be? Awesome, dr over dt. So 4 is how our radius is changing. So since that's changing, that would be dr over dt. And then it asks what's the area when the radius is 5. So what's 5? The radius. So let's take our derivative. So dA over dt is equal to, what would our derivative of pi r squared be? So 2 pi r, what are we missing? dr over dt. Bless you. Now let's plug in everything. dA over dt is what we're looking for. We're looking for how fast the area is increasing. So we don't have anything to plug in there. 2 pi is our constant. What's r? 5. And what's dr over dt? 4. So dA over dt, how our area is changing, would be 2 pi times 5 times 4. 5 times 4 is 20, times 2 would be 40 pi. 40 pi what? Not just centimeters per minute. But what are we talking about here? The area. So what would it be? Centimeters squared per minute. Example 3 says a spherical balloon is inflated so that its radius r increases at a rate of 2 over r centimeters per second. How fast is the volume of the balloon increasing when the radius is 4 centimeters? So what shape are we dealing with here? A sphere. So we're talking about the volume of the sphere. How fast is the volume changing? What's our volume of a sphere formula? 4/3 pi r cubed. We can label everything next. We've got 2 over r centimeters per second. What would that be? So the radius increases at a rate. dr over dt, since it's a rate, it'd be dr over dt. And it says when the radius is 4, so 4 would be r. Let's take our derivative. So dv over dt is equal to 4/3 pi would be our constant, so we can just put that out front. What's the derivative of r cubed? 3r squared dr over dt. We can simplify this a bit since we're multiplying by 3 and dividing by 3. We can cross those out. So dv over dt is equal to 4 pi r squared dr over dt. So let's plug everything in now. dv over dt is equal to 4 pi. What's r? 4, so 4 squared. dr over dt is 2 over r, but what's r? 4. We can plug 4 into our r, so dr over dt would be 2 over 4, which simplifies to what? 1/2. So dr over dt is 1/2. From here, just multiply. 4 squared would be 16. 16 times 1/2 would be 8. 8 times 4 is 32. So dv over dt is 32 pi what? It's volume here. Centimeters cubed per second.